awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Alright, so now let's discuss question number 4. So figure 2 here shows a graph of net force F against displacement S for a 3 kg block moving along a flat horizontal surface. If its initial speed is given here, and that's mean S equal to 0, means that displacement 0 meter, the initial speed is 5 meter per second. Okay, so determine the net work done on the block. Alright, so remember when we have a graph of force, okay, against displacement, so in order to calculate the net work done, so we can calculate the area under the graph. So remember, so we have this area and another one, this one. Okay, so for question number 1, okay, so we can write that W, okay, the net work, so net work is equal to area under Fs graph. Okay. So here we have blue and green color. So W is equal to, so we start with the first one, 5 minus 1. Okay. Alright, so area under the Fs graph. So we calculate the blue color first, 5 minus 1 times 2. Okay, so 4 times 2. And then plus, alright, second one, we're going to have 7 minus 5 times negative 1. 7 minus 5 is 2 times negative 1. Okay, so the answer is 6 joule. Alright, so this is the answer for question number 1. And then the final speed of the block. So remember, so bila ada soalan work and then ada kaitan dengan final speed, okay, U, V. So we relate with the work energy theorem where W net is equal to delta K. And this is given, okay, in the list of the formula. Okay, so W net is equal to 6 joule and then half mv squared minus half mu squared. So U is given. So therefore, we can just substitute where M is equal to 3 kg, V kita nak cari, minus 5 squared. Okay, so based on this equation, finally V is equal to 5.39 meter per second. Okay, jadi kena ingatlah bila ada soalan, dia kira work, and then lepas tu dia minta kita kira final speed, kita mesti kaitkan dengan work energy theorem where net work is equal to the change of the kinetic energy. Boleh? Okay. And then the third one, we want to calculate the instantaneous power, okay, at S equal to 7.2 meter. So remember, okay, so S is equal to 7.2 meter. So in order to calculate the instantaneous power, P, alright, so you can use equation FV, okay, which is FV cos theta. So in this case, F net, okay, F net mesti same direction dengan V lah. F net is in this direction, V in this direction, so theta is equal to 0. So cos 0 is equal to 1. So instantaneous power is equal to FV. Okay, so kita boleh substitute lah pada 7.2 So look at here, at S equal to 7.2 meters, you can see that the force is equal to 0. Okay, kalau at 1 meter, force is equal to 2. But at 7.2 meter, 7 to 8 meter here, you can see, okay, F is equal to 0. So when we substitute here, 0, okay, 0, V, therefore, instantaneous power for this question is equal to 0 watt. So kita hanya baca sajalah daripada graf yang diberi. Okay, So now finish question 4A. So let's proceed to question 4B. Alright, question 4B. The motor of a vacuum cleaner has a net power output of 746 watt. Calculate the work done by the motor in 3 minutes. So this is very simple question where P is equal to W over T. So make sure you just change time 3 minutes into seconds. Okay, so we want to calculate W. So W is equal to P times T, where power is given in watt. So make sure in watt. Okay, and then the time is 3 minutes times 60 seconds. Okay, so finally W is equal to 134,287 joule, or you can write as 1.34 exponent 5 joule. Okay, so this is the answer for question 4B. Now, let's move to question number 5. Okay, question number 5 is about circular motion. Okay, the radius of curvature of a band along a level road is 25 meter. So, given that, here, let's say we have a curve, okay, along a level road, means that a flat road. So, where the radius of the road here, we take it as R. Okay, it's given R is equal to 25 meter. Okay. The coefficient of friction between the road and the tires of vehicle is 0.35. So means that this is the car. Okay. So the speed V must be tangential. So remember the direction of the weight and normal force. Okay, weight and normal force. Contohnya weight ke bawah, normal force dia ke atas. Sebenarnya kalau kita tengok pandangan daripada sini lah, senang nampak. Okay. N is out of page. Awak tengok daripada atas, so means that N is out of page. Okay. And W, the direction is into the page. Ataupun kalau tengok daripada sini lah, kalau kita ada R. Okay. So, this is the car. Okay, let's say the car is moving in this direction. So, V must be tangential to the circle. Okay. And how about the direction? So, the direction of weight must be downward, which is into the page. Yang ni dia sepatutnya normal force dia ke atas lah. Out of the page. Awak tengok daripada atas, maknanya dia keluar daripada screen kita. Okay. And then, the only force that provide the centripetal force so that the car can turn the corner successfully is a frictional force. So, where the frictional force, okay, So, I just put frictional force F must be in this direction. Okay, F. Same goes to this one. Okay, frictional force antara jalan dan tayar tu mesti towards to the center. Okay, center of the circular path. Okay. So, for question A, calculate the maximum speed such that the vehicle can go around the bend safely. Okay. So, if you remember the equation, ada yang student dah hafal where V maximum is equal to square root mu RG, then it's okay. You can just really use that equation. But if you not memorize this equation, you can just derive the equation based on the total force FC is equal to mv squared over r, which is MAC lah. Okay, so in this case, the only force that provide the centripetal force and the force is directed to the center of the circular path is the frictional force. So means that the frictional force is equal to mv squared over r. So remember, mu n is equal to mv squared over r. And in this case, we can calculate the normal force from the total Fy is equal to 0 when n plus negative W. Kan saya kata tadi kan, the normal force out of the page. Okay, kita tengok kereta tu daripada pandangan atas. Tayar dengan jalan tu ada contact. Okay, tayar dengan surface of the road. So means that the normal force is upward. So the weight is downward, so negative. Therefore, the normal force is equal to mg. So when we substitute here, okay, the normal force is equal to mg. It's equal to mv squared over r. Okay, so you can straightly cancel m. Therefore, you akan dapat v lah. V is equal to mu rg. Itu saya kata tadi, ada student dia dah hafal dah formula ni. Maknanya bila soalan tanya maximum speed je, Okay, dia ada mu, dia ada R and then dia ada G, dia just guna saja. Tak salah pun. Tapi you kena faham lah mana dapatnya formula tu. Datangnya daripada mana? So, kita gunalah konsep total FC is equal to MAC. Okay, di mana centripetal acceleration is equal to V squared over R. Okay, so here we can substitute mu given 0.35 and then R is 25 meter and then the last one is 9.81. Okay, so the answer here is equal to 9.3. Alright, so the answer is equal to 9.3 meter per second. Okay, so finish question number 5. So let's proceed to question number 6. Okay, question number 6A. So we have a spring is mounted horizontally with its right end held stationary and a 0.4 kg body is attached to the left end. So the body is freely oscillating with a period of 0.5 second and the maximum displacement is 0.02 meter. Okay, so based on the equation, if we sketch the spring, okay, is attached horizontally where the right end held stationary, so means that this is the spring, okay, and this is the mass. Okay, the mass where M is equal to 0.4 kg and it is attached to the left end of the spring as shown in this figure. Okay, yang saya dah sketch ni lah. Alright, so let's say this is the equilibrium position where Y is equal to 0 and this is Y is equal to positive A and we consider this is Y equal to negative A. Okay, the body is freely oscillating with the period of 0.5 seconds. So T is 0.5 second and then the maximum displacement, which is the amplitude A, is equal to 0.02 meter. Alright, and then question number 1. Calculate the spring constant. Okay, so in order to calculate the spring constant, so make sure you remember this equation, K is equal to M omega squared. So kita tengok dekat depan ni, dia bagi tak equation K. Kalau dia dah bagi, senanglah, you tak perlu nak ingat pun. Okay, so dia tak ada kat sini. K is equal to M omega. Okay, so look at here. Okay, kinetic energy is equal to half M omega squared. Ataupun kita kata K, K is actually equal to M omega squared. So you boleh gantikan equation kinetic energy ni dengan half K E squared minus Y squared ataupun ini. Okay, equation of the potential energy half KY squared. Okay, so in this case, you must remember, kalau student tu tak tahu K is equal to M omega squared, then dia tak boleh jawab lah soalan ni. Okay, so in order to calculate K, so mass dia dah bagi, where you need to find omega, where omega is equal to 2 pi over T. So we need two equations here in order to solve for this problem. Okay, so K is equal to, the mass is 0.4, so let's write here 0.4, and omega is 2 pi over T, where T is equal to 0.5 seconds. So squared, so finally K tu you akan dapat lah. So nilai K is equal to 63 63 Newton per meter. Pastikan tulis unit. Okay, 63 Newton per meter. Or you can write the answer for K is 63.17. Actually, I got 63.17. Okay, 17 Newton per meter. Boleh? Okay. And then next, question number 2. Okay. Calculate the angular frequency of the oscillation omega. So omega is equal to 2 pi over T. Okay. Cumanya untuk soalan yang pertama tadi tu, kita dah cari omega pun kan. Tapi sebenarnya soalan yang pertama ni, you boleh selesaikan kalau you ada period dan you boleh guna formula 2 pi square root M over K. Okay, cubalah buat dua cara. So, mana-mana student buat ni boleh betul lah, kita kira betul. Okay, let's say lah, the mass is 0.4. So, let's try to find K by using this equation. So, sama tak? Dia akan lebih kurang sama lah. Okay, so sama jugalah. You akan dapat 63.17. Okay, Newton per meter. Sama. Okay, samalah. Alright, and then for question number 2 tadi, omega, okay, omega is equal to 2 pi over t, 0.5. So finally, you will get 12.57 radian per second. And then write the equation of motion of the body. So the equation of the motion, okay, so general equation for the simple harmonic motion, remember y is equal to a sine omega t. So you can just copy y, where a is 0.02 sine. Okay, for equation you can write omega. Kalau you nak tulis omega adalah 12.57 pun okay. Ataupun you nak guna in terms of pi. So yang ini tadi sebenarnya dia adalah 4 pi. Kan? So ini ataupun you boleh tulis dalam bentuk 4 pi radian per second pun boleh juga. So kalau equation, selalunya you nampak soalan-soalan dia lebih cantik dia tulis sebagai 4 pi t kan. Ataupun you nak tulis dalam bentuk desimal pun okey. Tak ada masalah, masih diterima sebagai jawapan yang betul. So 0.02 sin 4 pi tu boleh ganti 12.57 t. Okay, mana-mana pun betul lah. Okay, and then tulislah unit dia, where y is in meter, okay, and t is in seconds. Dah siap, okay? And then number 4, calculate the velocity and acceleration of the body at displacement y equal to 0.01 meter. So the question is really straightforward. So you can just use equation v in terms of y, where v is equal to plus minus omega square root a squared minus y squared. Very easy. Okay, you can use this equation. Equation ni pula dah diberi kat depan kan, so tak ada masalah lah. So v is equal to omega. So let's say omega tadi adalah 4 pi. Okay, and then square root a 0.02 squared minus 0.01 squared. Okay, you tekan calculator and then pastikan calculator awak betul lah awak tekan. Okay, and then you akan dapat plus minus, okay, 0.2176 meter per second. Okay. And then we want to calculate acceleration. So acceleration is equal to negative omega squared y. So substitute lah negative 4 pi squared y is equal to 0.01. Okay, so daripada sini you akan dapatlah jawapan A is equal to negative 1.579 meter per second squared. Okay, unit jangan salah, bukan meter per second, tapi meter per second squared. Okay. So finish that one, and then we want to calculate the kinetic energy and also the potential energy. Very easy, we can just use the equation, okay, of the kinetic energy, which is equal to half m omega squared, alright, a squared minus y squared. Okay, so you masukkan sajalah nilainya. Kinetic energy is equal to half, and then the mass is 0.4 omega 4 pi squared a squared 0.02 squared minus 0.01 squared. Okay. So press your calculator carefully. So finally the kinetic energy. Berapa dapat tu kinetic energy? Sekejap Calculate the kinetic energy and potential energy at maximum displacement. Sorry, maximum displacement, right? So maximum displacement means that dia nak add y equal to a lah, which is 0.02 meter. Okay, so kat sini tadi kita masukkan 0.02 meter. So kalau kita tak kira pun kita tahulah. Okay, so kinetic energy is equal to 0 joule. So kalau kita tak tahu pun sebenarnya kalau kita tahu the concept, so when the object at maximum displacement y equal to positive or negative a, the kinetic energy should be 0. Okay, and then the potential energy should be maximum. Okay, potential energy dia akan maximum. And then when the object is at y equal to 0, kinetic energy pula yang akan maximum. Okay. And then the potential energy akan equal to 0. Sorry. Is equal to 0. So, itu kena ingat lah. Okay. So now we can calculate the potential energy. U is equal to half m omega squared. M omega squared y squared. Okay. So ni you can substitute the value. So 0.4 omega is 4 pi squared. Y 0.02 squared. So U is equal to 0.01263 joule. 63 joule, or U is equal to 1.26 exponent negative 2 joule. Okay, so this is the answer. Alright, so let's proceed to question 6b. Alright, question 6b, we have a progressive wave with velocity of 150 meter per second. The frequency is given and the amplitude is given. And then it is propagates from left to right. So means that to the right, so the equation must be negative. So write the equation for the wave. So for B, so we want to write the equation of the progressive wave. Okay, and then generate equation Y equal to A sine omega t minus kx sebab dia bergerak to the right. So it's moving to the right. Okay. And then in order to write the equation, make sure you know how to calculate omega. And we must find first what is k as well. Alright, so omega. So we can write where omega is equal to 2 pi f. So frequency tu dia dah bagi kan. So omega is equal to 2 pi f. So we can find frequency equal to, omega is equal to 2 pi over 50. So the answer is 100 pi radian per second. And then how to find k? So k, since the question give the velocity of the progressive wave, so we can use equation V is equal to F lambda. Sama juga. Okay, so kita boleh kira lah. Okay, kita boleh kira lambda is equal to V over F, which is 150 over 50. So lambda is equal to 3 meter. Okay. Tapi ini lambda. Soalan bukan nak kira lambda. Soalan kita nak, kita highlight hijau tu, kita nak cari K dulu. So, K is equal to 2 pi over lambda. So, daripada sini, K kita boleh dapat lah. Which is 2 pi over 3. 2 pi over 3 per meter. Therefore, the equation Y is equal to amplitude tadi dia bagi dalam sentimeter. Saya nak tukar kepada meter. Kenapa? Okay, sebab saya punya K ni tadi, saya punya V dalam meter per second. Jadi saya punya K ni pun dalam per meter. Jadi bila you tulis equation, pastikan kalau semua dalam meter dan your amplitude also in meter. Okay? So 60 centimeter, which is 0.6 sine omega is 100 pi t minus k is 2 pi. Okay? 2 pi over 3x. Alright? So this is the equation, and then make sure you write the unit where y and x in meters and t is in seconds. Okay, so this is the answer for question B. Then question C. Okay, so this is about open pipe. So here we have 1 meter long. So L is equal to 1 meter. Okay, horizontal tube with both ends open produce a loud sound of frequency. Okay, 850 Hz when a vibrating tuning fork is placed at one end of the tube. So the loud sound occurs at the fourth overtone. So means that F fourth overtone untuk this one is for open pipe. Okay. So baca betul-betul, dia kata sini adalah fourth overtone, bukan fourth harmonics. Okay, fourth overtone bukan F4. Okay, N bukan equal to 4. Fourth overtone, F is equal to 5. Okay, 5. The number of harmonics is equal to 5. Okay, so 850 Hz. Okay, jadi untuk fundamental, okay, soalan pertama dia suruh kita sketch and label the standing waveform in the tube. So untuk kita sketch, kita kena faham. Untuk open pipe, the fundamental pattern untuk fundamental frequency, the pattern of the standing wave, saya selalu ingatkan dia adalah X shape. Macam tu. Sekejap X shape. Macam tu lah. Lebih kurang. Sekejap macam tu. 1, 2. X shape. This is fundamental pattern. Jadi kalau kita nak lukis untuk fourth overtone, okay, fourth overtone, which is equal to fifth harmonics. Okay, remember the pattern of X shape tadi mesti ada 5 kali. 5 times X shape. Okay, jadi kalau kita lukis, kita punya open pipe. Okay, kita lukislah, kita sketch. So ini adalah open pipe tadi. 1. Okay, 2. 3, 4, 5. Macam tu. And then make sure yang luar ni dia mesti adalah antinode. Okay. So, kalau you nak buat dotted line, so tak ada masalah pun kalau you nak buat dotted line. Okay, so you boleh buat dotted line macam ni lah. Okay. Macam tu. Okay, kita buat dotted line. So, antinode. So, hujung sini adalah antinode. Okay. So, ini adalah node, antinode, node, antinode, node, antinode. Okay, kita boleh labelkan lah semuanya. Okay. So, kalau you tengok, okay, for fifth harmonic, so we have one X shape. And then 2. Ini supaya awak nampak lah. Saya buat color lain 3, 4, and then the last one is 5. Mesti cukup tu. Okay. So labelkan lah. Ni antinode dan node, and then this is the length. Okay, the length. Sorry, this is the length of the open pipe. Boleh So B settle, B2. B1 tadi dah. Sorry, that one is B1. Okay, ini adalah B1. Sekejap. Ini adalah B1. And then B2, calculate the speed of sound in the tube. So we want to calculate V, where V is equal to, kita boleh guna formula V is equal to F lambda. So saya buat number 2 kat sini. So you can use equation V is equal to F lambda if you want. Okay. And then you need to find what is lambda lah. Ada 2 cara. Okay. So pertama sekali, frekuensi kita dah ada. Frequency of the fifth harmonics. Alright. And then lambda, you need to find lambda. Lambda tu nak dapat dari mana? So daripada sini you tengok pada pattern yang you lukis ni. Okay, so based on this pattern, remember, so this is half and this is 1 lambda. Okay, so 1 lambda and then we have 2 lambda, which is 2.5 lambda. Where 2.5 lambda, we can write L is equal to, kalau 2.5 berapa? 5 lah. 5 over 2 lambda. Okay, so 5 lambda over 2. Therefore, okay, you can calculate lambda is equal to 2L over 5. Where 2L tadi dia dah bagi 1 meter and over 5. So means that in this case, lambda is equal to, lambda for fifth harmonics which is 0.4 meter. Jadi bila you dah ada lambda tadi, okay, berdasarkan pattern yang you dah lukis pada soalan yang pertama, then you can find frekuensi you dah ada dah. Okay, and then lambda is equal to 0.4. Therefore, F is equal to, so that one is 0.4 times 850. Okay, so 340. So V is equal to 340 meter per second. Okay, remember frekuensi tu you mesti guna frekuensi pada fifth harmonics tadi. But lambda you mesti carilah. Lambda at fifth harmonics equal to berapa? So kita dapat 0.4 meter. Okay, itu cara yang pertama. So this one is method 1. Alright, so and then for the second method, so you can use equation frequency of the open pipe which is Fn equal to Nv over 2L. Dan equation ni adalah disediakan kat depan tu, boleh pakai saja. Alright, so from here, since we have F5, soalan dah bagi 850 equal to N is 5, V tu kita nak cari, and 1 is the length of the open pipe tadi. So daripada sini you nak cari V, jawapannya akan sama juga. Okay, so this is the answer. Okay, sama ada you suka nak guna method yang pertama ataupun you nak guna method yang kedua. Cumanya kalau you nak guna method yang pertama tadi, F equal to F lambda, make sure you find first what is lambda. Okay, awak kena tahulah L is equal to 5 lambda over 2. 1 wavelength, 2 wavelength, and tambah lagi half, 2.5 wavelength. Sebab yang kuning ni separuh. Tambah lagi separuh jadi 1. Ini pun separuh. Tambah lagi separuh 2. Tambah lagi separuh tu maksudnya dia adalah 2.5. L equal to 2.5 lambda. So kita tulis sebagai 5 lambda over 2. Boleh Okay. And then the last one, calculate the new fundamental frequency of the sound if one end of the tube is closed. Okay, so maknanya dia masih pipe yang sama. Cumanya kali ni dia kata kalaulah dia jadikan open pipe tadi sebagai closed pipe. Alright, so untuk closed pipe, senang sajalah you guna formula untuk fundamental frequency F1 is equal to NV over 4L. Dan equation ni dah ada dah kat depan. So fundamental frequency N is equal to 1. So you masukkanlah kan F1, length of the pipe tu masih sama. Kenapa masih sama? Sebab dia tutup sebelah saja. Dia masih pipe yang sama. So 4 tu tadi you ambil 340 yang kita dah kira ke atas tadi, which is the speed of sound in tube, and 4L is 1. Boleh? So finally the answer is equal to 85 Hz. Unit jangan salah lah. Okay. Alright. So now finish 6C. And then we move to next question which is 6D.